with any of these protocols and any port, and if it's relevant, master or slave setting. So this is our determination. Again, I'm using the default ones we have set up. These default sockets make it easy to talk about VisiLogic and about what we're doing. I'll give you some examples of other ports. Port 80, for example, is the web server port. When you load a website, the communication is over port 80. Yes, this is these are the configurations that we use in VisiLogic. I say that because we're using a 570, but it's the same for the 200 series, 130, 350, and the new 1040. Okay. Let me close this out. All right, so we've seen two uses here. We've seen VisiLogic, and we've seen remote operator. I want to do one more example where we're just going to bring up and show communication and connection with Modbus. Now, we're not going to go in depth with Modbus at all, but let me close this down. We will save this. Let's call it connect. Okay, and I'm going to close this. Save that. Okay, so I've prepared a Modbus master and a Modbus slave program. If you are experienced in Modbus, you know that Modbus is a master-slave protocol. What this means is that the master will read and write from the slave, and the slave does nothing but listens and either accepts or returns information. Let me just download these to my controllers, and we'll do a quick test. COM8 for this one. Yes. And we'll look at the examples quickly, and then we'll show them. We'll show how they're working. Okay, and I already have it in my 350. So what I have on my desk now is a V570 and a V350 connected to a switch, and in the same IP range as my computer, so I can download directly to them. Okay, and just one more second. Now, using any communication, we have two things to set up before we can communicate. The first thing is the physical layer. For example, RS-232, RS-485, CAN bus, or in this case Ethernet, is our physical layer. It's the physical line or medium that we're going to communicate over, and then above that is our protocol. So we haven't talked about our Modbus protocol yet, but let's take a look at the master example. Again, we're going to see, it should be very familiar in all of our projects, SB2, PLC name, TCP IP card in it. In this case, again, 102256 as our master, as our 570 as well. And in this case, we're going to use socket 3 configured on port 502. Okay. So all of these things we've seen. The new addition here is the protocol that we're going to run over it. So this is our Modbus IP config. We can find this under FBs and Modbus IP config. All of our communications have some kind of configuration. So we need to set up first our physical layer and then our communication. And again, we can take a look at this quickly. We just see that we've selected socket 3. We've determined that by deciding we're going to use socket 3 on port 502. We talked about default ports earlier. In general, port 502 is used for Modbus IP. It's very standard that a lot of devices support that and use that. We're going to connect to our slave device, which is in this case our V350. I gave it the IP address 10.2.2.57, and we're going to see that we've set it up to listen on port 502. Okay. So So again, don't worry about the Modbus portion so much right here. We're just using it as a tool for this example. What we need to do after we've initialized our communication is use our TCP/IP connect function. Again, we can go to com TCP, and we see now we have a connect and a close TCP. So as we said earlier, TCP is a handshaking protocol. It requires a connection and also a disconnect to finish the communication. We didn't discuss the system bits we have available here, so let's do that now. I'm going to go ahead and click on operands in the bottom. I'm going to bring up this browser. Let's go online here and take a look at these system bits. We have starting at system bit 141. If the Ethernet card exists, which means that the controller does identify that it has a card in it, this should be high. The card is initialized. This should be high as well. Now we have an initialization for socket 0, 1, 2, and 3, all separate bits. Again, by default, these should be initialized to something, our default settings, so they should all be high here. And now some interesting ones, 147, 8, 9, and 150, socket 0, 1, 2, 3, connected. Now this is very useful information. It lets us know if indeed we've created a connection. System bit 151 we see is the Ethernet link. I'm going to remove the network cable from my 570. We see it's gone low. Actually, all of our initializations have gone low. So let me plug it back up. Okay. Our data rates are, if we're either in 10 megabit or 100 megabit, but other useful ones are 155, 6, 7, and 8 if we have a send in progress. Now these are important because we can use them to determine if we have if our socket is open to communicate on. So let me minimize these down again, and let's take a look at how we're going to perform our TCP/IP connect. Let's open this block, and let's just look at the information inside it. We can select the socket we want to use. In this case, it's 3. We're using socket 3 because we've decided and we've initialized our socket 3 for this specific communication. The remote port, again, this is the device we're going to connect to. I'm sorry, remote IP. And remote port, this is the port that our device should be set up to be listening on. So we need to set up on the other end port 502 to listen mode or to slave. Let's close this. Let's look at the parameters that we're going to use to make sure that we can connect. So we have the positive transition of MB4. Take a quick look at the display. We notice there's a connect button. This is MB4. When we press MB4, for one scan, net2 should go high. So when we press MB4, if SB142 is high, this is if the card is initialized. If SB146 is high, if we have our socket 3 initialized. MB0 we use as our function in progress bit. We see we got that from our Modbus config. So what this normally closed contact means is if we do not have a function currently in progress. And SB150, again, normally closed, if we do not have socket 3 connected. Then we're going to perform the connect on socket 3. Okay, let's go ahead and look at our slave side. It should look similar again because we're setting it up for Ethernet communication. In this case, the PLC name is slave. The IP address is 10.2.2.57, and this is good. This is we saw on the master side. It should be the device we're connecting to. Okay, and our socket 2. Now the difference here is we have it set to slave. So on the master side, we called it the master, and on the slave side, we called it the slave. The slave, again, is the device we're connecting to. Okay, so let's go ahead and let me bring up the master controller view. I'm going to go online with the controller. Okay, let me bring up these system bits as well. Where can I put this so it looks good? Okay, so I'm going to press the connect button. What we want to see is that our system bit here, Ethernet socket 3 connected, is low. When I click it, we want to see that we go high. So I pressed it, and we've gone high. And we can look at the HMI now, or the screen. Notice we added a couple pieces of information here. Socket 3 transmits and receives, Ethernet socket 3 status initialized, card status initialized, and connection status. Now we're connected. I'm going to go ahead and just press close, and we should see that we're not connected, and our system bit has gone low, but we'll just connect again. Good. So does that make sense so far? If anyone wants to give me a yes or a no. Yep, okay, great. Let me close this out and let's continue to look at what we have in our master application. Okay, so we've set up our communication. We've performed our TCP/IP connect. And now we're free to perform our Modbus functions. So we won't really get into these, but let's just take a look. We press our button MB5. This is the read button on the HMI. We're going to perform our number 3 read holding register. Notice that we use, again, system bit 150 if we are connected, and MB0, which is our Modbus function in progress here. These are very important bits because we don't want to try and perform a read if our socket is busy. Actually, we can take a look at both of these nets. We like to use this configuration for communication. You can think of it as a sample and hold configuration. When we press a read button, we're going to set a bit, in this case MB1, the request to read. MB1 is going to go high, and it's going to wait until MB5 is high and MB0 is low. So if we set MB1, we press the button. If we are connected and we don't have a function in progress, we'll perform our read function. And then we're going to reset MB1. So it is going to wait until the Modbus is not in progress, and then we're going to read. This is nice because if we connected the push of a button directly to the read function, if we connected our push of a button directly to the read function and we were in progress, we might get a collision, or you could think of it as a traffic jam. So that's why we use this configuration. We do the same thing below for our write. Okay. Again, we won't focus on Modbus, but so what are we doing here? We're setting up our communication. We're configuring it. Step 1. Step 2 is actually connecting to the device. So again, this is the property of TCP. You can think about it as we're opening a doorway, and then we can pass through the doorway. And of course, when we're done, we're going to use our TCP/IP close. We'll take a look at this function block. It's pretty simple. You just select the socket we want to close. Okay, so is that clear? I just wanted to point out really with this example that with TCP, we create a connection, we perform our tasks, and then we can close the connection. Now we said we can only connect